Today we're going to be talking about visualizing latent prints, but before we talk about visualizing latent prints, we need to learn what latent prints are. And so at a crime scene, there are three kinds of fingerprints that we can find. The first one being a plastic print or a 3D impression, three-dimensional impression. These could be left behind in wax and soap, in paint that's not wet to the touch, but still kind of soft, maybe tar. Um, then there's patent prints, which are visible prints. So you have a material on your hand and you leave your fingerprint behind on a surface, and your fingerprint is visible. So, like paint or blood that's on the hand that can then transfer onto another surface. And finally, what we're going to be talking about today is latent prints. Latent prints are not immediately visible to the naked eye. So no matter how clean your fingers are, you have oils that are on your hand, and those oils transfer to anything that you touch. And that's what a latent print is. And so they are left behind at a crime scene if someone is not um, wearing gloves. And you can't see them. And so, in order to be able to see them, we need to visualize them. And we visualize them using different methods, depending. We're about to talk about it. And we do that to then collect and identify the fingerprint. And so, there are physical methods that we use to visualize fingerprints, and these are used mostly on non-porous surfaces, meaning surfaces that won't absorb material. Um, and so the most commonly used is called powder dusting. I'm sure you guys know about it, or at least have heard about it. But basically, what powder dusting does is those those powders actually adhere to the oils that are left behind on the surface, those fatty components of residue. That's a fancy way of saying oil. And then there are different kinds. There's black powder, there's fluorescent powder, there's magnetic powder. They're all different kinds of powders, actually. Like there are so many more. There's also like white powder. But basically what you want is a contrast. So you want, if you have a light colored surface, you would use a black fingerprint powder to make that contrast so you can see the visualization better. Whereas if you have dark surfaces, you would use a white powder or a fluorescent powder to make that happen, or to make that more visual to you. It also depends on what surface you're dusting. So a magnetic powder, which you see here in the picture, is really good for any kind of shiny surfaces or plastic. So if you imagine like a plastic cup or your phone, right, I would use magnetic powder because very shiny. Um, Another kind of physical method is something called small particle reagent. And this small particle reagent is a spray, meaning that you would spray it onto the surface, or you would immerse whatever you're trying to get a fingerprint off of into the reagent, like dunk it into there. And it's made up of this chemical compound called molybdenum sulfide. And I just like saying that name. I mean, you don't have to know that it's molybdenum, but anyway, I like it. It's a fun word. Um, anyway, this small particle reagent actually adheres to lipid components in the residue. So um, the powder is really going to catch on anything that it can catch on, whereas this reagent just adheres to those oil components, nothing else. Um, and so this is used a lot on evidence that has been wet. So whether maybe it was in the water, or perhaps it was soaked in blood or something like that, the small particle reagent will actually just adhere to those fatty residues. So we're going to go into chemical methods, and we usually use chemical methods on porous surfaces, except for one. There's an exception there, which we'll talk about in a moment. So I'm just going to go through them, and let's go. So the first one that we're going to talk about is silver nitrate. It's actually pretty antiquated. This was used in photography processing. I don't know if any of you um, are into photography and have developed your own film, but this is what is actually used in that process. And so the silver nitrate actually reacts with salt to make the print turn black, and it's silver oxide is what it turns into. So basically the salts that are left behind in your fingerprint, so maybe from perspiration, from your sweat, if you leave that behind, then this can react with the salt. It, like I said, it's antiquated. We use other things now to look at fingerprints. So what else do we look at? Oh, I'm sorry. This um, this process is best used on a porous surface like paper. Also, best on paper, which is actually more preferred over doing the silver nitrate now, is actually iodine fuming. And so, even though it's not truly a chemical method, because iodine is a chemical itself, we call it a chemical method. But basically, what happens is that we fume iodine, and the iodine's in the air, and it gets caught in the oil of your fingerprint. And it works best again with paper. But the problem with iodine fuming is that it's really short lived because right, that iodine can then fume out of the oil. It's not a chemical reaction. And so in order to make it a chemical reaction, you use starch, like cornstarch, and they have like spray starch, fancy stuff. But anyway, you can take starch and actually paint the fingerprint with that, and it turns into this, actually it turns purple when you do that. But that makes the print permanent for you to be able to then, photograph or scan and then identify. Ninhydrin is actually the more preferred method of using something for paper. So this is actually the most commonly used on paper. And ninhydrin is great because it reacts with the amino acids in your residue. So not the salt, not the fat, but the proteins. And that's what, right, amino acids make up proteins. And it's pretty slow to develop, but if you expose it to some heat, it actually goes pretty fast, and it develops this really pretty purple color. Like I said, good on paper. And this is the preferred method on paper, as far as I know. So super glue fuming, this is pretty preferred by a lot of fingerprinting people. A lot of CSIs actually have a mobile fuming chamber. So they will fume super glue in the field onto certain things, because when you dust for prints with powder and you lift it, that print's gone forever. But if I super glue fume it first, it makes a permanent impression, like it almost casts, that sounded weird, casts the fingerprint, the oil, to be permanent. And so I can do all kinds of stuff with that. I can brush it with powder. I can, do other kinds of chemical methods, but basically that super glue fuming is locking in that fingerprint and makes it less fragile and allows me to do more things with it. And so basically, right, those super glue fumes react with the oils in your print residue to make this white impression. You actually really need humidity, like moisture in the air. So you need to kind of have water in the mix as well. It's basically good for like anything. It's good for metal, glass, adhesive tape, plastics. You really need to be careful to not melt anything, because you are using a little bit of heat to get that humidity and that fuming. But like I said, it's good for most anything. And finally, there's crystal violet, which is also really fun. Crystal violet is a dye that actually stains the oils purple, and it's mostly used on the adhesive side of tape. So if I were, let's say, to kidnap someone and use duct tape in that kidnapping, um, it's likely if I wasn't wearing gloves that when I ripped the tape, um, I would leave fingerprints behind. So it's really, really useful for the adhesive side of tape. Because if I were to use powder, that would, it would stick to the adhesive side of the tape. So, anyway, that is an overview of how you would visualize latent prints at a crime scene.